Okay, so the next topic that I wanted us to cover is the sequence and series topic, and this is basically patterns, and we're going to be looking at the arithmetic sequence, and also be looking at the quadratic, and there's the quadratic sequence and there's the geometric sequence. So we're going to start with the arithmetic sequence. What we have is this formula for the arithmetic sequence. We have this formula: Tn is equal to a plus n minus 1, that in bracket multiplied by t. So this is the general formula, or the general term for the arithmetic sequence. So the key things that we need then to know about the arithmetic sequence is how can we find the general term or the formula for that sequence, and then what is the first term of the sequence, and also what is the first difference, or what is the constant difference, the constant difference being t. So given a sequence, the first thing we'll jump to is identifying our a, which is the first term, and then the second thing we jump to is finding our d, which is the constant difference. How we find the constant difference is saying t1 minus t2, second term minus first term, third term minus second term, just to confirm that the difference is constant. And then with an example, we're just gonna quickly illustrate how this comes to play. Okay, we can see here that we have a sequence, an arithmetic sequence, that increases by 4. It increases by 4, minus 6, minus 2, 2, 6, 10, increases by 4, and it's constant. And then the first term is minus 6. So like I said, these are the key things that we need to take note of as we approach the arithmetic sequence. Okay, the first question is find the general term. To find the general term, we take our a and d and we substitute into the general formula. We take our a and d and we substitute into the general formula. Our a being minus 6, and then our d being 4. Minus 6 there and 4 there. And then when you simplify that by putting that 4 inside, when you put it inside the 1, you'll have minus 4, and then you put it inside the n, you'll have 4. So basically here you'll have minus 6, and then you'll have plus 4n, and then you'll have minus 4. And then the minus 6 and the minus 4 will give you the minus 10 that we see here. So the general formula for this particular case is equals to 4n minus 10. Okay, what did you do? You got the first term, and then you got the constant difference. The constant difference is 4, and then you just put that and you simplify, and then you have the general term or the formula for the sequence. Okay, second question is which term of the sequence or in the sequence exceeds 84? So here we want the term number or the position of the term. So we have n, for example, with minus 6, this is the first term, minus 2 is the second term, and this is represented by n in the formula. 2 will be the third term. So Tn is equals to 4n minus 10. So that n in the next to 4 is the position of the term. For example, to find the third term, for example, you say term number 3 is equals to 4 times 3 times 3, and then you minus 10. 4 times 3 is equals to 12, you minus 10. 12 minus 10 is equals to 2. So it means the third term is equals to 2, and that's very much correct. So this is the formula for finding. But what I want to highlight here is that the n represents the position of the term. So which term in the sequence exceeds 84? So we want to know, for us to get to tn that is equals to 84, how many terms do we have to pass? So we have to pass 1, 2, 3, 4, 5. That's what we're trying to find. So hence the first step of this question is saying Tn. Okay, it's saying Tn must be greater than 84. So remember, 84 is the term itself, and then n is the position of that term. So we want to know when are we at term number, which position are we at when we get to term 84. So that's what we're finding out. And then we see that when we say 4n minus 10 is greater than 84, we then solve by taking the 10 to the other side, it will be positive and make 94. And then divide both sides by the 4, divide by 4 there, and then you'll have that n is greater than 23.5. And then since we're dealing with our whole numbers when we're looking into positions, it means the n here is going to be equals to 24. So this is which term in the sequence? It's term number 84, because it's term number 24, because to find 84 we must be at 23.5. We must be at greater than 23.5. So yeah, but just note that n represents a term number. Usually how they ask this question is which term is term number, which term in the sequence is term number 84, or is equals to 84. So which term is equals to 84? In which case you do the same thing and then say, okay, it's probably term number 23, or it's term 23.5. But here we round up or down, but we'll see with examples. Okay. Number C, the value of the 40th term, 14th term. So term number 14. How do you find that? We know that this means that position number 14. You take that 14, you put it in the n. Put in the n, and then that's it. You will have 46. That's how you find the term. So they give you a term number or the position of the term, and then you take that position, you put it there, and then with that you're gonna get what the term is. And then how many terms are there in the sequence? To find how many terms are there in the sequence, here we are given the last term. So the last term will be the one to indicate how many terms are in this sequence. So what do? We say Tn is equals to 4n minus 10. The last term is 110, and then you put that there, and then on the other side it's equals to 4n minus 10. And then you want to separate like terms, so you leave that 4n alone there. You take the 10 to the other side. The 10 goes to the other side to make 120, because here it's negative, it's going to be plus 10 that side to make 120. And then you divide both sides by 4. And then you get 30, n is equals to 30. What does it mean? The position of the last term is 30. The last term is 110. What does it mean? It means that we have 30 terms in total. And that's the brief about the arithmetic sequence. There's nothing that they really ask outside of these basics, but we'll look into other type of questions that they ask when we look at the question paper questions. Okay, without a waste of time, we now look at the geometry sequence, which sort of like has a similar behavior. We have the Tn, okay, we have the general formula, Tn, which is equals to a r to the power n minus 1. R represents a common ratio. There we had a common difference. Now we're dealing with a common ratio. And then a is still the first term. N is the position of the term. Is the position of the term. So this one may be a bit confusing. Is the position of the term. And then how do we work with this? Same as before, the first thing you want to figure out is the common ratio, because actually for you to know that a sequence is geometric, it must have a common ratio. So the common ratio in this case, you have 6, 18, 54. You say 18 divided by 6, and you say 54 divided by 18. And then we see that the common ratio here is going to be 3. So the 3 will continue. So this sequence continues with a multiple of 3. So you take the current term multiplied by 3, the current term multiplied by 3, and you continue. So the 3 is the common ratio. Okay, the next thing you want to find is the first term, that is very simple. First term is 6. Okay, first term you have it, a common ratio, you have it. You put those into there to find the general formula. Yeah, to find the general formula. But let's hear what questions they are having. They say you must give the next two terms. The next two terms from 54, you just multiply that by 3. 54 times 3. And 54 times 3 is going to be 150 plus 12, 162. So the next term there is 162. And then you multiply this further by 3. And then you continue, that will give you the second term. Okay, it will give you the next two terms. Okay, the next thing they want is the nth term. When they say the nth term, what they mean is they want the general formula. They want the general formula. Actually, in this particular case, to find the next two terms, they opted using their formulas because they know already that term number 4 is the next term, and then the next one is term number 5. So you have 162, the other one will be 486. Okay, then the general formula, you take your A, you take your common ratio, you multiply them. So that's it, even if you leave it here. Yeah, I don't think you really have to simplify it further, but they do simplify it further there. Okay, and then we have this next question: how many terms are there in the sequence? Always to deal with the how many terms, we must look at the last term. So we attempt this as the previous thing. So we say Tn is equals to that. Here they are using the simplified version, and we will put the last term, which is 118,098. And then the first step they do there is divide by 2 both sides to get rid of that 2. To get rid of this 2, they divide by 2 both sides, and then that side will be having 59,049. And then 59,000, you can write it as 3 to the power 10. You can write it as 3 to the power 10, and then this is equals to 3 to the power n. So it means the exponents are equal because the bases are the same. So this is just the most basic questions that you can deal with when you're having a geometric sequence, but we'll dive more into the questions as we continue with the content itself on the exam papers. But key takeaway is that to deal with geometric, you need common ratio, and then you need the first term. To deal with arithmetic, you need common difference and the first term, and then that's it. You start dealing with them. And then we have, I think it should be on the next slide or on a previous slide, the quadratic one. Okay, it's here. We have the quadratic sequence. The quadratic sequence is an extension of the arithmetic sequence. So you do the first difference, you don't find anything, and then you have to do the second difference. On the first difference, you find that there is another pattern that is continuing. So by not finding anything, I mean that you don't find a constant, or yeah, you don't find a constant difference, but you find a pattern that is continuing in a sensible way. Okay, so you have 6, you have 17, you have 34, you have 57. You minus, and then you get 11, you get 17, you get 23. And then you see now you can have a second difference that is going to be constant, and that is 6. You see, so this is the difference between that one, the arithmetic, and the quadratic. This one has 2 differences, and the second difference is constant. Okay, what is the general term or the general formula for this quadratic? Is this one. It's more like the quadratic formula. So Tn is equals to a n squared plus bn plus c. So you need to find a, you need to find b, you need to find c. How are you going to find a? So we say a, we say 2a. 2a is equals to the second difference, which is 6. What do they do here? 2a is equals to 6. So you look at the second difference and then you equate that to 2a, and that will help you to find a. And then to find b, now that we have a, you take 3a plus b. 3a plus b. So this 3a plus b is general computations. This must be equals to the first difference. The very first of the first differences, which is 11. So the first one there, and then that will help you to find b, because already you'll be having a from the previous computation. And then to find c, you then say a plus b plus c. A plus b plus c is equal to the first term. In this case, is 6. So with this, now that you have a and b, you can find c. After finding a, b, and c, you then plug it back to that equation, and then you have the equation of the general. What can I say? You have the general term of the quadratic equation, and then that's it. That's it. All you do is do the differences, and then you say 2a is equal to the second difference, 3a plus b is equal to the first difference, the very first one, and then a plus b plus c is equal to 6, which is the first term. So that's it. So also this one has is the one that's asked more directly compared to the other ones, because it has this its own computations. But other than that, that should be all the things we cover when it comes to sequence and series. The ideas we cover, and then we have some series because they were doing sequences, and then I'll cover these series in a very short video because they have 2 slides. Yeah, that will be the next video that I'll upload. But for now, just comment any question you have, and then I'll address them as soon as possible. Yeah, enjoy your studies. Thank you.